Very good morning, friends. This is Hemant Pradhan. Again, welcome to the e-learning hub YouTube channel. My dear friends, I have started a lecture series on quantitative methods, particularly based on the CBCS syllabus. Those students who are pursuing their undergraduate as well as your post-graduation, this course content would be helpful for them. So, because of the COVID pandemic situation, students are actually not able to get the proper offline classes. So I thought of making the video series so that this content would be helpful for the students, those who are actually facing the problem. So this is the basic purpose behind the making the different video series. So dear friends, I have already have taken a lecture on limit and continuity, and what are the meaning of limit and continuity, and what are the different characteristics of limit and continuity. So dear friends, today we shall be learning about what are the algebra of limit and how we are going to actually calculate the limit of a function. So there are different methods actually: additive method, multiplicative method, constantive method, and division method. And also we can calculate the left hand side method and right hand side method. So let's discuss one by one how we are going to calculate on the different method the limit of the function. So first we are going to talk about the additive method. So under this additive method, when we have to calculate the limit of a particular function, we will calculate the limit based on the particular term. We will take the separately particular term, and whether if the plus sign is given, the difference is plus sign is given, and the minus sign is given, we will put the plus and minus sign. Here it is stated that the limit of x tends to a function of x plus minus gx under bracket this is equal to limit of x minus a fx plus minus limit of x minus a gx. It simply says that here there are two terms given, fx and gx, and if you calculate the limit, then we'll take the limit of each term separately. It means for the fx term we have taken a separate limit, limit x tends to a fx, and whatever the sign is given there, whether if the plus is given, then you have to put the plus, and if the minus sign is given, then you have to put the minus sign. Clear? Then and also I have taken for the next term, that is gx. For the gx term also we have taken the limit. So it means if there are combinedly given the plus minus sign is given, then we will take the separately limit of the each term. For example, here it is given that the function is x square minus 4x plus 3. Okay, and where x tends to 2, it means we will take the limit value of these functions separately. Here it is stated that the limit x tends to 2, x square minus 4x plus 3 will design first in this way. Then for the each term x square, 4x and 3 will take the separate limit. Okay, so here you can see that the limit x tends to 2, x square has taken separately, minus, here it is minus sign is given, so we'll take the minus sign. Limit x minus x tends to 2 of the 4x term, okay, plus, here plus sign is given, so we are taking the plus sign. Then limit x tends to 2 of the term 3. Okay, so here we have taken the separate limit, we have taken the separate limit of each term. Clear? So what will happen now? Put the value of x, that is x tends to 2, it means x equal to 2. You put the value of 2 wherever the x term is there. So here you take the put 2 here, then what will happen? 2 to the power 2. Clear? Minus, what will happen here? 4x, it means this is equal to 4 into 2. Clear? Then here 3, here there is no x term, then the limit of this constant term would be 3. Clear? The limit of the constant term would be 3. So here we can say the limit what you have taken here, x square. So from this x square we can get the 2 square. Okay, so here we will get the 4, then minus 4 into 2 we have taken, this is equal to 8 plus 3, then what would be this? 7 minus 8, this is equal to minus 1. It means we are going to get the value of this function, limit of value of this function is equal to minus 1. Clear? So in this way we can able to get the in the additive method we can able to get the limit. Clear? We will take the each term separately and putting the limit and calculating the limit of the each term separately, and combining that we can able to get the functional value or the limit of the function value. Clear? I think clear. So like that, the another term is given here or another function is given, so you have to evaluate this. So how you can evaluate the limit? Like that, you have to here it is written that limit x tends to 0 and x square plus 2x plus 5. So here we will take the limit of each term, x square separately, 2x separately and 5 separately. Clear? So the limit x tends to 0, x square plus 2, limit x tends to 0, x plus limit x tends to 0, 5. It simply says that a constant term is there, then constant term will be taken away. That we will see in your what? Constructive method. If there is a constant term is there, so that particular constant term will be, if suppose there is 2x is given and that constant term is 2, so that constant term will be taken away and we can write down the limit x tends to 0 of the variable x. Clear? So in this way it has written. So what will happen now? Put the value of x equal to 0 wherever the x term is there. So here we'll put x equal to 0, it means 0 to the power 2 plus, in this case if we are going to put the value of x, then what will happen is 2 into 0 or 2 into 0 we can say, then plus, if there is no x term, then simply the limit value will be that exact constant term, that is 5. So what we get? I get 0 plus 0 plus 5, this is equal to 5. So here the limit of this function is 5. Understood? Okay. So I think you people are clear how we are going to get the limit by the additive method. Clear? By taking the each term separately, we are able to calculate the limit. Next come to the what? The multiplicative method. Under this multiplicative method, if the product of the two term is given, then we'll take the limit of that product term separately. Clear? So as it is mentioned here that in the box, limit x tends to a fx into gx. If the two term and these two term are multiplied, the product of the two term, limit of the product of the two term, that should be limit of the each term, the product of the limit of the each term. It simply says that if there is limit x tends to a fx into gx, then this is equal to limit x tends to a fx into limit x tends to a gx. It means separately we have taken the limit and we have multiplied it. Clear? So here the two term is given, x minus 4 and x plus 5. The limit x tends to 3. Here the limit x tends to 3. So we can take this, the limit x tends to 3, x minus 4 into x plus 5. In this way, this is equal to, we can take according to your formula separately for x minus 4 term and for x plus 5 term. So here write down in this way, limit x tends to 3, x minus 4 into limit x tends to 3, x plus 5. Clear? So next come to the what? Again your multiplicative theorem, the additive theorem is applied here, because here it is given that x plus 4 or x minus 4, sorry, then we'll take the limit for this particular x and also limit for the particular value 4. So here the additive method is also applied. Like that, limit x tends to 3 for the x minus limit x tends to 3 for the value 4. Then in this way, here it is also written as x plus 5. So for the x also we are take the limit, and for 5 we will take the limit. So here limit x tends to 3 for the x term plus, here is the plus term is given, so we will put the plus. The limit x tends to 3, 5. Clear? So right now you put the value of x equal to 3. Right now you put the value of x equal to 3 wherever the x term is there. So here x term is there. you will put 3 here. Here it is, here x term is there, you will put the 3 here. Then what we are going to get? 3 minus limit of x tends to 3, 4 equal to what? That particular term. Limit of that constant term is that constant term. Clear? Then this equal to what we are going to get? 3 minus 4 into 3 plus 5. It means 3 minus 4 equal to how much? Minus 1, and into 3 plus 5 equal to what? 8. It means you are going to get minus 8. 1 into 8 minus 1 into 8, this is equal to minus 8. So in this way we can able to derive the limit of the function by taking the separately if the product of the two term is given. So we are going to take the limit of the each product separately, and by taking this we can able to get the limit of this function. Clear? So you have to prove that here, you have to prove that if limit of x tends to a is given, so you have to prove that limit equal to a to the power n. How we can able to prove this? How we can able to prove this? You see that we know that what is x to the power n, this is equal to x into x into x. It means n number of times x is multiplied. So according to your what multiplicative theorem, what you will take? If the limit x tends to a is there, clear, for the x to the power n, for the each term we will take the limit separately. Then we can say the limit x tends to a of x into limit x tends to a x for n number of time we are going to multiply. Then though we have taken the limit x tends to a x, it means in place of x we are going to put a. So whatever the limit term that we are going to get, that is equal to a into for the n number of time of a. So if you multiply the n number of time of a, then what we are going to get? We are going to get the a to the power n. So in this way, this is the limit. In this way, the limit x tends to a, x to the power n, this is equal to a to the power n. Clear? So let's come to the what? Your constantive method. It means limit of a constant. If the constant term is given, then how we are going to get the limit? Clear? So it is stated that the limit x tends to a, where constant term is multiplied with that particular term, then the constant c will be taken away outside and we can calculate the limit. So for example, if here it is given that 2x square, okay, so here constant term is 2, then we can able to calculate the limit x tends to, suppose x tends to 1 is given, and this is 2x square. Clear? So we'll take this 2 outside. Then what we can write down? 2 limit x tends to 1 x square, this is equal to 2 into limit 2 into in place of x you can write down 1, then 2 into 1, this is equal to 2. Clear? In this way another term is given 25x cube, where x tends to 5. So 25x cube where x tends to 5. So if you take the limit of this, then limit x tends to 5 of the term 25x cube. So here constant term is what? 25. So you have to take it outside. So we can write down 25 limit x tends to 5 x cube. Clear? Right now you put the value of x equal to 5 here. Okay, so what you are going to get? You are going to get 25 into x equal to what? 25 into 5 to the power 3. Then 5 to the power 3 equal to how much? 125. Then you multiply 25 into 125. Then you will get 3125. Okay, if you multiply this 25 into 125, you are going to get 3125. So the value of limit value of the function would be this 3125. Okay, so in this way, for a constant term, if the constant term is given, then you have to take away that constant term, and whatever the x value or whatever the value will be given there, the variable, so you have to put that limit on that particular variable. Clear? But whenever you are talking about limit of a constant, it means limit of x tends to a of a, then the limit of that particular constant would be a. So that particular constant, it means if the limit of x tends to 2 is given, and here it is written as 5, we can see here it is no value of the 2 or no value of the x, then we cannot put the value of x here. So the constant term that 5, the 5 would be the limit. Clear? Suppose for example, another example we can take, if the limit x tends to 0 is given and we have taken the 10, that is the constant. So here there is no x value, so we cannot put the value of x equal to 0 here. So in this case the limit would be 10. Clear? I think so. Next come to the what? Different example. Okay, so you will do at your own. If there will be problem, then we will discuss later. Clear? 5x cube plus 3x square minus 2x. So according to your additive theorem, you will take the each term separately, the limit of the each term separately. Okay, then according to this, it is given here the limit of x tends to 2, 5x cube plus 3x square minus 2x. So here for the limit x cube, you will take a separate limit. Here it is given for x 5x cube term. In this way, you will take the limit x tends to 2, 3x square minus limit x tends to 2, 2x. Separately, you have taken the limit. So here again your constantive theorem is applied, because here the term is 5x cube. So you have to take out this 5 to the outside. Then what will happen? This is 5 limit x tends to 2, 3x square. Sorry, 5 limit x tends to 2 x cube. Clear? So for this term also we can able to get through your constantive theorem, that is 3 will be taken out to the outside, and then we will put the limit value, limit x tends to 2, x tends to 2, that is sorry x square. Okay, so in this way we can able to get the limit. For the each term, you will put the limit of the each term. Then after taking this constantive method, okay, right now you put the value of the x equal to 0 from wherever the x term is lies. So here if you put the x equal to 2, then what will be here? X equal to 2, then 2 to the power 3, then this term, the value of this term will be 5 into 2 to the power 3 equal to 8. This is equal to how much? 40. Okay, so in this way, for this term 3 equal to 2 to the power 2, this is equal to, you can get 3 into 4. So what we will get? That is 12 we can get. Next, if you put in this case, it is 2 into 2. So what we can get? We are going to get 4. So what we get? We get, that is 40 plus 12 minus 4. Okay, so this is equal to 52 minus 4, which is equal to 48. Clear? So in this way you can able to get the limit through your constantive method, multiplicative method, and your additive method. And another method, that is your division method. Okay, and under this division method, if the quotient is given, or the term is in terms of your quotient is given, for example the term is x plus 2, and it is given that 2x plus 3. So you will put the limit separately for the numerator and separately for the denominator, like this. Here it is written that the limit x tends to 1, okay, and our numerator is x plus 9 and denominator is 2x plus 5. So we'll put the limit x tends to 1 for x plus 5, sorry, x plus 9 separately, and the limit x tends to 1 2x plus 5 separately, and we will calculate. If you put the x equal to 1 here, then what will happen? We'll get 1 plus 9. Then if you put the value of the x equal to 1 here, then what we will get? 2 into 1 plus 5. Okay, so this is equal to, the value of the function would be 10 divided by 7. 10 divided by 7. It simply says that if the limit of a function x tends to a fx, that is a numerator term, divided by denominator term, then we will calculate the limit of the numerator term separately and denominator term separately, where you have to notice that the denominator term, that is the gx, should not be equal to 0. Clear? Then only we can represent in a quotient or division method. Okay, I think you people are clear. Next, come to the what? Left hand side method and right hand side method. These two methods are very essential, and you have to clearly understand what is the left hand side method and right hand side method. Okay, in our earlier classes, from the definition of limit and how the limit we are going to calculate, I have already talked about. If x tends to a and if the given function is fx, so that fx will approaches toward the limit value. Okay, if x, the value of x approaches toward the your constant value, the positive constant value. Okay, so we have taken, in our earlier classes we have taken what? Lower side and the upper side. And lower side, it means that if you are going to calculate the limit from the lower side, that is called what? Left hand side method. It simply says that if x tends to 2 is given, we will take the lower values of x less than 2. We will take the values of x which would be less than 2. It means we are taking 1.9, 1.99, 1.999. Okay, but it will approach, increasingly it will approach towards the x equal to 2. It will approaching toward the 2. Clear? So the formula for the left hand side method is that limit x tends to a to the power minus fx, this is equal to limit h tends to 0 function of a minus h. It means whenever we are calculating the left hand side method, so we'll denote this left hand side method as limit x tends to a to the power minus. If the minus side is given here, then we'll say that it is left hand side method. Or if we are going to calculate the limit for the left hand side method, we'll denote the limit in this form. Clear? Then we'll take, and wherever the x is term is there, so we'll take the x equal to a minus h, x equal to a minus h for the left hand side method. Okay, so here it is stated that the limit x tends to a to the power minus fx. Clear? This is equal to, we can say, the limit h tends to 0, f equal to a minus h. It means we'll take, in terms of whenever we are talking about the x tends to a, here we will take the always x tends to 0. We'll convert that limit into h tends to 0. Clear? Then our in place of h will take the, this is equal to a minus h. Clear? So here it is written in this way, and after calculating that, the limit h tends to 0, f a equal to, in place of h, what we will put? You will put the 0, then this is equal to 0. Then we can write down that limit h tends to 0, this is equal to function of a minus, or functional term should be denoted in this manner. It means we are going to the limit value of this function left hand side method equal to in this term. Clear? So we will take an example so that you would be understood clearly. Clear? So here if we have given the limit x tends to 0 and which is equal to 1 by x. Clear? So now we have to calculate the left hand side limit of this function, okay, or this functional value. We are going to calculate the left hand side method. Okay, so what we will do, first we have to calculate that in this way, x a to the power minus, okay, of this function x. Clear? And this is denoted in this form, limit x tends to 0 where f equal to a minus h. Clear? So for this function we can write down this as limit x tends to 0 to the power minus x tends to 0 to the power minus 1 by x, we can say. Clear? Then this is equal to limit h tends to 0, okay, then function 1 divided by, in place of x, what you have to put? You have to put a minus h. Clear? So now what you will get? You will get the limit h tends to 0, okay, then in case of your what, h, you put the value of the 0 right now. We will get 1 divided by minus h, because we will get here the limit x tends to 0 to the power minus is given. Okay, so what we have to do? We have to do the limit h tends to 0 where 1 divided by 0 minus h. If you are denoting the limit in terms of your what, x tends to, or your, sorry, h tends to 0. Okay, then because, so what we are going to get? We are going to get limit h tends to 0 1 divided by minus h. Clear? Okay, then so if you put the limit h tends to 0 1 divided by minus 0, so this would be minus infinity. It means that left hand side method would be minus infinity. Clear? So in this way we calculate the left hand side method. And another example is given here, that is limit x tends to 3 x square plus 3x. From the left hand side method we have to calculate the limit. So what we have to do? We have to first write down in this manner, x tends to what, it is 3, constant term is 3, then we are putting the 3 to the power minus 3, then this function would be written in this way, and whatever the term is there we will write down x square plus 3x. Clear? Next you have to write down in a x h tends to 0, and if you put the h tends to 0 in this form, then whatever the value of the x would be there, you have to write down in place of that a minus, or that constant 3 minus h. Clear? So write down the limit h tends to 0, then 3 minus h square plus 3 limit h tends to 0 3 minus h. It means I also applied the your constitutive theorem here. Clear? So what will happen? We will get in this manner. Here it is written that limit x tends to minus 1 x square plus 3x. It means here if you denote that limit of in terms of your s tends to 0, in place of x we will write down the 3 minus h. Okay, so here 3 minus h, your where square is there, then you will put the square also, plus 3 into limit h tends to 0 3 minus h, this is equal to, we will get, because 3 minus s square, if you put the value of h equal to 0, then what we will get? 3 square, which is equal to 9. So we get the value 9 here. Clear? In this way, if you put 3 minus h, or h equal to 0, then what we will get? This is 3 and it is multiplied the 3. Okay, then we will get the 3 into 3, this is equal to 9. Then 9 plus 9 equal to what? 18. 9 plus 9 equal to 18. In this way we can able to get the left hand side method of the limit value. Clear? In this way also we derive the right hand side method. So let's see how we are going to calculate the right hand side method. So whenever we are talking about the right hand side method, it means we are talking, if we are talking about x tends to 2, okay, and the constant term is 2. So from the right hand side method we will calculate from the upper side or from a greater value of the 2. It means from 2.1, and that greater value will decline towards the value 2. It means we will take from 2.1 to 2.01, 2.001 in this way. Clear? Okay. So here the value of the x that will approaches toward the constant 2. Clear? So, and whenever we are denoting the right hand side limit, we will write down in this way, that is limit x tends to a plus, a to the power plus. It means it is a right hand side limit. We are taking a greater value, and the greater value approaching toward the your constant value, the positive constant value. Clear? So, and where the x term is written, we'll write down here a plus h, that is the formula. But in case of your what left hand side limit, what we are taking limit x tends to a to the power minus, okay, and in place of your what x we are taking a minus h. But in case of your what right hand side limit, what we will take limit x tends to a plus, okay, and where x term is there, you have to write down a plus h. Clear? Okay, and you will calculate here the limit h tends to 0 f a plus h. Clear? So what will happen, we'll take it means that we'll take limit x tends to a plus. This is equal to, if you are denoting this limit in terms of your h tends to 0, what will happen, in place of x we will write down what a plus h. Clear? A plus h. So this limit or the right hand side limit can be represented in this way, unlike your what left hand side limit method. Clear? So this is the form, and whatever the limit value will arise, that will happen h tends to 0, this functional value will be function of a plus, as in case of a left hand side limit we are getting a minus. Clear? So let's take an example here. Let's take an example how we are going to get the right hand side limit. Okay, for example, the term is given that, for example, the term is given limit x tends to 3, where x square plus 3x, okay, x square plus 3x, this term, and for this function we are going to derive the right hand side limit. So what we are going to do, first we will write down in this manner limit x tends to 3 plus, okay, then we will denote here x square plus 3x, okay. Next, if you denote this term in terms of your h tends to 0, then what will be the functional form here, the h tends to 0, h here h tends to 0. It means in place of x you can write down right now, you can write down what a plus h, this is equal to x. So here x, in place of x you will write down what the limit h tends to 0, then 3 plus 0 square, okay, it is written in this way, plus 3 limit h tends to 0, 3 plus 0, this is equal to 9. It means we have taken separately for the h, and also we have put the value of 0 here, okay, then we will get the value of this right hand side method. It simply says that the same procedure will be applied, but you have to look into that the plus term. The main thing you have to notice is that for the left hand side limit, whenever we are talking, we have to write down limit x tends to a to the power minus, and whenever we are taking the limit x tends to a to the power minus, there is a left hand side limit, and where we'll put x equal to a minus h. Okay, if we are denoting in terms of your limit h tends to 0, okay, h tends to 0, so where we will take x equal to what? X equal to take a minus h. Clear? But whenever you are talking about the right hand side limit will take the limit x tends to a plus, and where x term is there we have to write down a plus h whenever we are representing this in terms of your what? Limit h tends to 0. Okay, so this is the theme. And how we are going to get the limit? You will derive the limit for the right hand side of this function also, and you have to tell me if there will be any doubt, then we will discuss. I think you people are right now clear. So how the limit of the function can be exist, we can say whether the limit of the function exists or not. If the left hand side limit is equal to the right hand side limit, so for a particular function we can able to derive both the left hand side limit and right hand side limit. And after deriving the value of the left hand side limit and right hand side limit, if the value get equal to the left hand side limit to the right hand side limit, then what will happen? We can say the limit exists. We can say the limit exists. So here it is written that the limit of a function exists when the left hand side limit and the right hand side limit both exist and they are equal to the common value of the limit. And whatever the common value of the limit that will appear, so that must be the, it means LHS is equal to RHS, left hand side limit is equal to right hand side limit. This is equal to that limit value or the functional that particular common limit value. Clear? So in this way we can able to get the, or we can able to derive the limit value whether the limit exists or not. Clear? So you have to calculate the illustration 12 whether the limit exists or not for this function. First you will take the left hand side limit, then we will take the right hand side limit, and after getting the value of the left hand side limit and the right hand side limit, you have to calculate whether they are getting equal or not. If they are getting equal, then we can say the limit exists. If they are not getting equal, then we can say the limit does not exist. Okay, so in this way we can calculate the limit of the function by taking the left hand side and the right hand side approach. Okay, so you will do more numericals, then you will able to clearly understand. Clear? So in our next class we shall be talking about how the evaluation of limit that is carried out. Okay, so there are two types of limit: algebraic limit and we can say non-algebraic limit. For the algebraic limit, how we are going to calculate the limit value, and for the non-algebraic limit, how we are going to calculate value, that we are going to talk about in our next class. Okay, and there are different methods in calculating the limit value. Okay, and what are the different methods? So there are different types of methods we can able to calculate the limit. So what are that methods? That is direct substitution method, factorization method, rationalization method, method of evaluating the algebraic limit when x tends to infinity is given there. Okay, and using the some standard rules. So we shall be talking about all these things in our upcoming classes one by one. Okay, we will go in detail what are the procedure of the calculation method. Okay, so thank you this much for today. Have a nice day ahead. Thank you.